Okay, so in the last chapter, we learned graphically in tabular summaries of data. Now in chapter 3, we will learn how to describe data numerically. That means we will try to crunch number. That is, we develop numerical summaries of data. We examine measure of centers, measure of variability, and measure of relative position. So section 3.1. Measure of center. So the objectives of this section is that by the end of the section, you will be able to calculate the mean for a given data set. Calculate the mean for a given data set. Find the median. And describe why the median is sometimes preferable to the mean. Is sometimes preferable to the mean. And find the mode of data set. And describe how skewness and symmetry affect this measure of center. How skewness and symmetry affect this measure of center. So the most well-known and widely used measure of center is the mean. In everyday usage, the word average is often used to denote the mean. So to find the mean, of the values in a data set, to find the mean of the value of a data set, simply add up on the number and divide by how many number we have. Add up on the number. And divide by how many number we have. So, for example, you have a table of the price of the cell phone. We have eight different types of cell phone with the price $200, $200, 600, 200, 800, 250, 200, and 300. So this is a price for a population of cell phone. So, to find the mean of the cell phone price, we take 200 plus 200 plus 600 plus 200 plus 800 plus 250 plus 200 plus 300. So this is the total price of the 8 cell phone divided by the number of the cell phone, and we get it is 343.75. So now so there are few notation that we will use throughout this course, and most of the time statisticians will use those notation. The population size, is always denoted by capital N. So in the previous example, capital N is equal to 8. The sample size which refer to how many observations you have in your sample data set is always denoted by lowercase n. The sum of all the data is denoted by capital sigma of x. The population mean is denoted by mu. So mu, it will be the sum of x over capital N. The sample mean is denoted by x bar. So X bar, this is the most important symbol used in these books. So X bar will be the sum of all the sample divided by the sample size n. Now suppose that in the previous example, we take randomly 4 cell phone with the price 200, 600, 250, and 300. So this is a sample with a sample size n equal to 4. And the sample mean X bar will equal to the sum of X divided by n. In this case will be 200 plus 600 plus 250 plus 300 divided by 4. And that is 337.5. Of course, a different sample would give you a different value for sample mean. So, the mean is sensitive to extreme value. To extreme value. Now, for example, if I add a very expensive cell phone of the price of 10,000 to the population of 8 cell phone, then the population mean will be 200 plus 200 plus 600 plus 200 plus 800 plus 250 plus 200 plus 300 and plus 10,000. Divide by 9. So let's see, how much is it? 200 plus 200 plus 600 plus 200 plus 800 plus 250 plus 200 plus 300 plus 10,000 divided by 9. So you will get that it is the price now, it is around 1,416 67. That is more than 4 times the mean value 343.75. So when we add this extreme value, then the price go up 4 times. So for situation like this, we prefer a measure of center that is not so sensitive to extreme value, and the median is just one of such measure. So the median you can think of it as the median. This is the median data value when the data are put into ascending order. Half of the data value lie below the median and half lie above. So if the sample size n is odd, then the median is the median value. And lie at the n plus 1 over 2 n position. When the data are put in ascending order. Is ascending order. If the sample size n is even, then the median is the mean of the 2 median data. So let's come back to the example of the price of telephone. Now, to find the median for the set of data of 8 cell phones, first we have to put the price in the ascending order. So we have 200 is the lowest one, 200, 200, 4 times 200, so next is 250, 300, 600, and 800. So if we have 8 cell phone, the price of 8 cell phone we put in increasing order. Now in this case, 8 it is even. Then we have 2 midden data. It is a 2 midden data. Uh, 200 and 250. So the median price will equal to 200 plus 250, the average of these two. So it's 225. Okay, now suppose that we add one more cell phone with the price 10,000 to the data. In this case, we have 9 samples. So 9, this is an odd. So the midden data, the midden position is this position. And therefore the median will equal to 250. You can see that you add some extreme value, but the median is not so sensitive to the data. So the median. Is not sensitive. To extreme value. Okay. So the next measure, it is the mode of a data set is the data value that occurs with the greatest frequency of a data set. Is the data value that occurs with the greatest frequency So in the previous example, 200 is met four times. Therefore, the mode here is equal to 200. So this is not number 4, but it is the value of that mode, the value of that data. That means the mode here is 200. It may happen that no value occurs more than once, in which case we say that there is no mode. If more than one data value occurs with the greatest frequency, then we would say that there is more than one mode. Data set with one mode are unimodal, and data set with more than one mode are multimodal. So, multimodal. With more than one mode. If no data occurs more than once. Skewness and measure of center. So, if we have a bell-shaped graph, then the mean, the median, and the mode are the same. Or you can say that they are close to each other if it is not close to bell shape. If it is left skewness, so the highest point it is the mode, right? So the median is the median. Will be less than the mode and more than the mean. And the opposite. If it is right skewness, then the mode will be less than the median. Here the median is the median point. And less than the mean. Okay, so it is section 3.1.